All right, folks, today we're looking at section 2.6, which is entitled Solving a Formula for a different variable, or how did they put for a specific variable. We've been mostly looking at equations that had our one unknown value in it, the x value. Usually we can use any letter, and manipulating the extra terms, the variables, is what we're solving for, but moving those other numbers around so we get the variable all by itself, you could say, 1x equals something. Well, our formulas are usually built out of lots of variables, lots of letters. For instance, just that perimeter formula, for instance. Not going to do much with it, I'm just writing some things down, right? You could think of all three of those letters as being different variables, different values. And we could actually be given any one of the three there and figure out, given two of the three and figure out the missing one. So sometimes we want to make that job easier by sort of rearranging and solving for one of the other variables or letters in that equation. Even just length times width, here's a formula, no numbers, right? That's a formula. And every one of those letters is an unknown number, stands for some potential value there that we could plug in. Again, if we knew the area and we knew the width, we could figure out what the length was. And if we were looking for the length, maybe we would want to rearrange this formula, have it set up for us so that length equaled everything else on the other side by itself. So that's kind of what this is all about. We use the same exact solving techniques as we do with those equations, the conditional equations where there's a number, there's lots of numbers in there that we're trying to get rid of or move around. And we just have to do it with the variables. We add or subtract the variables, multiply or divide by those variables to try to get the one specific one that we're trying to isolate all by itself. So there are all those formulas that we used for geometry, for instance, where the letters stand for the concepts in the problem, like P for perimeter, L and W, length and width, H for height, maybe something like that. But we could just approach it totally abstractly and just say, here's a bunch of letters, A, B, C, and how do I get one of them alone? And then when you get to a specific context, formula, the letters might look different, but the same techniques or processes is what we want to use. So I'm just going to start out with something kind of basic, right? I'm making up a formula using ABC. I've got these three letters, all right? This says that this quantity is the product of whatever those other two quantities are. Well, what if we are instructed, or we have a reason to, on our own, to solve for one of the other variables over here, all right? What do we need to do to get that variable alone? Now, right now, I'm just gonna, for instance, say, oh, this is really something like that, saying that 10 is equal to 2 times x. How do I get this x alone? It's being multiplied by 2. You divide by that number that's in front of it and divide on both sides. When you look at the numbers, it makes sense. For some reason, somehow it's just straight letters, and people kind of throw out their techniques. They forget their techniques. So, but dividing by that thing that's multiplying what we're after, dividing by that number, is how we get the x alone. Well, we're going to do the same thing up here, right? We're going to do the same thing up here. I want to get the b alone. It's being multiplied by the c. How do I undo that multiplication by c? I divide by that c. So I'm going to take both sides of that equation and divide it by c. All right. I left those two together like they were two factors, and I kind of made a fraction. Now when I do that, notice I had to do it on both sides. I can't really simplify this at all. It just shows the operation that would be happening if there were real numbers in there. But by canceling that out, now I have that B equals A divided by C. Just happens to be the B on the right. I could rearrange it. I could turn it around if I wanted to. So here I'm showing, I'm going to call it a simple form, where the only thing being done to what we're after is a multiplication. So we're going to undo that multiplication by using the opposite operation, a division. Okay, erase that one. Now, I'm gonna, there, I can make it slightly more complicated, slightly. Again, just unknown letters, right? This quantity is the result of the product of these three different numbers. Each of these represents some number you could plug in eventually. And I want to get the Z alone. This is really very similar. I just decided to the ABC, I just decided to add one more letter. These two things are both multiplying this piece here in the middle that we're after. They're all multiplied together, but I want to get this one alone. So I want to undo the multiplication that these two are doing to that Z value. All right? So I'm going to divide by both the Y and the Z. Just writing it as a second step, a next step. All right, I'm going to divide by Y times W. Like those two factors are now both being divided by. If I multiply them together, I get one number, right? And of course, have to do the same thing on the other side. If I do that, over here I did that on purpose, because here's a common factor. It's like saying I can divide them both by 2 and cancel it out. But gee, I can divide them both by 3 and cancel that out. Or the Y's cancel out. It leaves just the Z, or Z over 1. I'm going to call it just Z. I'm going to just kind of flip it around. But here's what's left, right? Z then is equal to y, X, whatever that is, divided by Y times W. This is what I would, Mom sets you up like this probably, and this is what you have to click on, that little fraction format and type those in like that. Again, what I'm after is being multiplied by something, so I undo that by dividing by those extra things. Can you do this one? This is actually an interest formula, the rate times however long, the rate times time. This is just, you do it, right? How do I get the T alone? That last couple have made any sense? That should be a kind of a quick one. Does it make sense to get the T alone? I have to get rid of the R, undo whatever operation it puts it there. So I'm going to divide both sides by R, and I did this backwards. Is that, hopefully you got there, okay? There we go, keep going. Just checking, make sure everybody's here. All right, still just 3 numbers. I don't know what they are, but they're variables. So they're variables. This one right now, you could say is solved for X. X is the result of whatever all this stuff is over here. And it's this number divided by that number. Well, I want to rearrange it so I know what y is as the result of all this other stuff. What do I have to do to get y all alone? What's being done to the y right now? The y is being divided by this z value.
You need to multiply.
Pardon?
You need to multiply.
Right, you need to multiply by this thing that's dividing it. Thank you. So I multiply both sides by that z value. Now that's multiplying this fraction times a z. If you want to think of it as z over 1, that's fine. But it's just, you know, say a whole number or something. Here they go away, right? I did that on purpose to cancel. So my y value, and I'm going to kind of flip it around, okay, do y first, is now the product of x and z. Just turned it around. So in this case, you know, the first couple I did, what I was after was had something multiplying it, so I divided. Here I made up one where what I was after has something dividing it, so I had to multiply, do the opposite operation. But just like it was a number problem, you know, just like it, this is just like that, right? How do I get x alone? I multiply both sides by 2. That's what I did here. I multiplied both sides by z. What if I took this one, same one, what if I wanted to solve it for the z? This is like 2 steppers here, 2 now. This is different because what we're after is in the denominator. And we really haven't dealt with that in our conditional equations or other equations usually. You know, the variable.
Don't you flip it?
Pardon?
Don't you flip the reciprocal?
You flip it. Now, I had something else in mind, but let me think about that for a second. If I'm after the z, now if I flipped it, if I just multiply by the reciprocal and cancel everything out, I just get a 1. Okay, so I don't think that's quite it. Let me suggest this, all right? What you're after is in the denominator, you have to get it out of the denominator. How do I do that? I'll abbreviate that. The only way to, right now it's saying I'm dividing by what I want to get at. Well, to get it out of there, I have to multiply it. I have to multiply it by both sides by that quantity to get it out of the denominator. So really, I'm going to look like we ended up a minute ago. We were here. I have to multiply by the z, but actually it does cancel it out over there. But it's over here now. Right? It's over here. We've still got a z hanging around. I'm still trying to get that z alone, but I had to do that first step to move it out of a denominator. It eliminated it over there, but introduced it over on this side. I'm still trying to get the z alone now. How do I get the z alone on this side? This is like the first problem I did. Z that's supposed to be an ugly multiplication dot. It's being multiplied by this x, so I'm going to divide by
x.
Yeah, got to divide this side by the x. So we kind of move things around a bunch, but there's what you get. Right, so if it's in the denominator, if what you're looking for is in a denominator, you know, if I just like divided by y, imagine this with me, right? If I divided by y or multiplied by 1 over y and canceled, I'd end up with 1 over z. That's not the same as z. So just getting rid of the y still leaves it in the denominator. So not the same, not good enough. Just get rid of that. That wasn't. Okay, so.
I have to leave early today, so when I leave, can I just say bye? Is that all I have to do?
Bye or log out and go, and maybe I'll hear the ding or something. And
Okay.
no, I understand people have to come and go. I count on you as adults to be responsible for you know, taking care of what
I just have another meeting to go to after, or
fine. Yeah, it's okay.
Thank you.
Yeah. Let's see. This might be a real one. Volume is a result of pressure divided by, I'm mixing up. This is trying to remember those chemistry letters. Pressure, volume, temperature, they're all related to each other. I might have them all mixed up. But let's solve this one for P. All right, can you do that? What we've been doing makes sense. That should be kind of a quick one. And then we'll do it again and we'll solve it for T, okay? So we'll just do the same thing I just kind of did with the XYZ, but with a different group of letters here. You can almost take one and then turn it into the other, I suppose. We kind of saw that in that last example. If I'm going for the P, I'm hoping you got that one done. If I multiply both sides, I'm going to be lazy. Both sides by T. I get P is TV. TV time? No. TV, VT, right? Multiplication is commutative. The order doesn't matter. 2 times 3 is 3 times 2. How do I get the T alone, though? If I was back where I started, right? Back where I started, I was trying to solve for T. I actually have to do the exact same thing, right? Because it's in the denominator. So I'm going to multiply both sides by that T, and it gets me to here. But now I have to go one more step to get the T alone. Got to get rid of the V. All right, so hopefully that sort of clicked. That's what we're after there.
Can you give us a little bit extra time to actually work through them before you start working through them?
Yep.
Thank you.
Sometimes you do get a letter, excuse me, a number in there, right? You get a number in there. So you deal with the number just like we've been dealing with those numbers if we have to get rid of it or move it or cancel it out, right? So this is really exactly like my first couple or second example where I had X equals WYZ or something like that, right? I have 3 things multiplied together. How do I get to just saying B alone? I have to undo the multiply by 3 and undo the multiply by C so I can get B equals something. Can you do that? Just happens to be there's a number there. Yay, a number, not a variable. Checking our list here. Do you need more time? Let me know. I guess I see heads down still, so. I want to get the B alone. Undo the stuff that's affecting it. Do it to both sides. I mentioned earlier in the term that this shape, well, mom is You have a newer version that actually provides you with a fraction template, right? Looks like something like that. And you, if you click the drop-down menu, and you could put in the fraction yourself. If I was, say, trying to write this horizontally, let's call it like that, myself, those are two factors in a denominator. That's I was thinking ahead, sorry. Divided by, I need parentheses, B times C. Just look at that to compare the, oh, I'm sorry, that's a 3. I was mixing up problems here. Just look at that to compare, right? These two things are two factors, one number in the denominator. If I'm trying to write it like this, in order to make, I have to make this a group, otherwise order of operations would think I'm dividing by 3, but then turning around and multiplying by a C. So here I have to group them in the denominator. If I was writing this on paper, for some reason, I would call this like a horizontal method rather than a vertical fraction. Okay, just, but like I said, our new mom version, you don't, yeah, you don't have the old one to worry about. New mom version gives you the fraction.
What section of the textbook is this covered in?
I'm sorry, say it again.
What section of the textbook is all of this covered in?
This is 2.6.
Thank you.
All right. So here we go. Similarly, now I put another number in front of this one. Now you could think of this as multiplying by a half or dividing by 2. But if I'm trying to get this C alone, I have to take care of both of these values that are affecting it. You know, how do I cancel out? Another way to write this, you might actually see this kind of problem looking like this, right? See how those two mean the same thing. This one maybe even kind of helps show you what am I going to have to do to get that C alone, right? I got to do two different things. Get rid of the 2 and get rid of the B. Or get rid of the half and get rid of the B. So either way, really, with either version here, I'm going to do it in 2 steps, okay? I'm going to get rid of the 1/2. How do I cancel out dividing by 2 or multiplying by a 1/2? I'm going to multiply by a 2. Now it's over here, but it's a bunch of factors. 1/2 times the 2 is going to be a 1, cancels out. Of course, I have to do it over here. I'm going to stick it in front, have 2a. So these two cancel each other out. 2 over 1 if you prefer. I'm still trying to get that C all alone, whatever it is. So I've got one more thing to do. I'm multiplying by B here, so I have to undo that. Opposite of that, we've done this a few times now. Divide both sides by B. Reading it, turning it around, huh?
I have a question when you have a second, when you finish that.
Pardon?
I have a question when you finished it. Can't you also do just divide half times B times C? Just half, divide by half times B and it'll get the same answer. You just gotta divide by A.
Well, I'm going to just say that this with a fraction in the denominator is not an acceptable form.
Okay. Okay.
Does that make sense? You see that?
Yeah, yeah.
We don't divide by a fraction. So this is how, here I am dividing by a fraction with multiplying by the reciprocal.
Okay, cool. Thank you.
Yep. I don't think mom will let you even do that, but it's bad form. All right, everything I've been doing so far has basically been multiply or divide what we're after. Well, what if we've got add or subtract in the way? Do the opposite thing. I want to get the b alone. I got to get rid of this thing. It's added an extra number. This is, you know, this is this kind of problem. I got to get rid of that 3. I got to get rid of this c. What do I do over here? Subtract it. So I'm going to subtract. Whoop. Get this out of the way, okay? I'm going to subtract the c. And because we don't actually get to combine the numbers over here, I'm going to write it all horizontally. You know, if I did minus c over here, it doesn't look quite right because I don't get to actually make one number out of it. I'm going to see all of that. So here's a minus c. And just to be real thorough, there it is, right? I subtracted the c from both sides. C minus c, those are going to go away. So I get a minus c is equal to b, or turn it around if you prefer. B is a minus the c. Hopefully you can see from this one, if I was after the c, I'd do the similar kind of thing. I'd subtract the b from both sides. All right, that's a multiplication, and there's an added. This is like something that looked like that, because I'm going to say, let's find the z. Let's get the z all alone. All right, the z here is in the same spot. If you were working that with numbers, you'd get rid of the 5. We'd have just the numbers as 3x, and then we'd get rid of the 3. So we have to do something similar over here. Thinking, what I want is in this term. Usually it's best then to do whatever is necessary to get rid of the extra terms, add or subtract. That's often the best first step. So
I have to go. Bye. Have a great day, guys.
bye, see you, good luck.
Thank you.
So I'm going to subtract the w from both sides. And I just wrote it all out there. Okay, subtracting the w from both sides. These two cancel each other out. X minus w is equal to y times z. I still want to get just the z. It's being multiplied by y. So I need to divide by that y. Now there's a couple of ways you can write this. If I divide by the y on both sides, I could write it like a fraction like that over here. All right. That's probably the easiest way to do that. And if you use the fraction mold in MOM, for instance, it would let you do that pretty easily. Put these 2 in the numerator and that in the denominator. Remember, if I had, like if that was a number, I could multiply by the reciprocal, or I could say, like, cancel it out. Instead of dividing by y, I could multiply by 1 over y. Are you okay with that meaning the same thing, right? Dividing by y. Just pointing out, trying to show this could be written as 1 over y, like a fraction, and this all in a parentheses. It's kind of more complicated looking, but, right? This y on the bottom is the same as 1 over y, like having 1/2 times a bunch of stuff or something like that. This is probably easier to put together. Okay? And let's take the same one here. What did I do? I did z. Leave this here. Well, let's see. What if we want the w? W is kind of a separate term all by itself. All I have to do is get rid of this term. Now this is two pieces multiplied together inside that term, but I can just subtract it like it was one quantity. And I don't know what it's going to turn into multiplied together. You know, I don't want to try to divide by it because then I actually have to divide the whole side of it and it doesn't cancel. It almost makes you divide by the W. I just subtract it. And I'm just going to stick it out here on the end, right? Y times z minus y times z is going to leave this W, and I'm going to rearrange it here. So that means the W here is equal to just one term subtract minus the other term there.
Can you do another one similar to this?
Yeah.
Thank you.
Keep going. As far as our, real formulas or the equation shapes that we use, there are several real common fixed forms for our equations that we're going to use in the future, and then the formulas, area, base times height, those kinds of things. You're going to see your mom problems are using what looks like our usual formula letters and some Y's and X's and things like that. I'm trying, it's hard for me to show examples without actually doing the mom problems. So I'm using different letters than a lot of your mom problems, but try to look for the similar shapes, basically analyze it for what do I have to do to the letters that are there to get at what I'm after. So how about, just put something in here. This is very similar. What if I want to get that B all alone? If it's too different, whoever just asked me that question, I'll go back and make it simpler and another one. But it's still the same kinds of situations. I have what I'm after in this term with some stuff, and then I have an extra term. Usually you want to get rid of that extra term. Can you go a ways yourself? Get that B alone.
So would you just subtract the 3 and the C, just like the last problem?
Well, you can't subtract those. If you're after the B, it's being multiplied by those. So to cancel them, you would have to divide to get them out of that term.
But the last problem, you'd subtracted y times z from both sides.
But they were all by themselves, right? There wasn't a third factor in there. I could subtract them together. Like if this was xy, what I would do would be subtract this x first. If this was xy, I could subtract the xy.
Okay, thank you.
Together. But eventually we're going to have to divide to get rid of the 3 and the c. If I divide right now, This is like what I say, don't divide first because you'll get messy fractions and the whole problem. If I divide right now, I'd get fraction, fraction, fraction. I don't want this to be a fraction. I'm going to subtract that x first is what I would suggest. If I do that, if I subtract the x from both sides, is this okay if I don't show the extra? I would get to here if I subtracted x. Is that okay? And you could go from there now. How would you get rid of the 3 and the c? Well, I'll write it in here. I don't want to get in trouble here for not showing enough here. All right, I subtracted the x from both sides. Now the term, you want to get, that maybe that's a way to think of it. You want to get the term that has what you're after alone, and then undo the extra stuff in that term. I got rid of the extra term. Now I have to undo the 3 and the c. And we've already sort of talked through, you would want to divide by those values. To divide by them here, right? 3c or 3 times c, and same thing over here. So there it is. Cancels that out, it just leaves a b. Again, multiple pieces in numerator and denominator, but if you use that fraction mold in Mom, notice, yeah, put them together, put the multiplication dot in if you want, but that would be good enough like that.
Thank you for explaining that. The last problem was confusing because of the subtracting y times x, so that cleared that up.
Good. All right, well, you're just gonna keep going. Do it again. This is very similar. All right, I mixed A's and B's and X's and Y's. So what I was sort of just describing, here's the term that has what I'm after. It has an extra term next to it, added or subtracted. So usually the thing to do is do what you have to get rid of the extra one. So this is alone. Then you can look at what you have to do to that one more after that. So what are we going to do first?
So you would subtract the by from both sides?
Yes, yes.
Okay, cool.
That makes sense. Well, I'm going to skip the middle step here. If that, does this make sense? If I've lost anybody, please just let me know. I've subtracted the by and it's gone. Okay, there, I'll do this. I subtracted the by. So this is alone on the left side now. My equal sign kind of moved over, but it was subtracted from what was there. Now, one more step to get the x all alone.
Then just divide by the a on both sides?
Exactly, good. There, that'll be it. B times y, right? If you put them right next to each other, mom knows. Mother knows best. No. Yeah. All right, see if I can mix it up a little bit. All right. Here. Several things in here. So, which usually means there's more than one way exactly to do it. One way might be easier than others. I'm thinking about the very last formatting at the end. But first step, I think there's one clear step for the first step. One best, put it that way. Now this is more complicated than it's been, but the piece that we're at, the C that we're after is here in this term. And again, there's this extra term. So the first step is
Subtract.
subtract this x, right? If I subtract the x, I get a minus x. Now, here's where kind of there's a couple things to do, right? A couple things you could do.
Can you just multiply by the, or sorry. I'm gonna get rid of the b. Now I don't know. I was gonna multiply the b on both sides.
I'm sorry with my ears. Did you say B or D?
Yeah, b, like b as in Bob.
If I multiply by the B, I just put another B on top. It didn't go away.
Okay, so divide by it?
Yeah, that's one. Yeah. Oh, pardon me. Drop. Yes, the B is like a number, right, on top. If I divide by it, I have to divide both sides by the B. It'll cancel it out. Let's do that here. If I divide by the B, it really can just go in the denominator, or you can think of it like 1 over B. Does that make sense? Or over here, dividing by the B, I just put it like that. I wrote it like that. You just think about that, but really I could have just written it in here and canceled. But however it makes sense for you on when you show your work. Does that work for you? Now if I divide by that B, whoops. Over here, then, it still leaves C divided by the D. I'm after the C. Now what do I want to do?
Now just multiply the d on both sides?
Yes. And here now where it's important to understand the form that I'm about to come up with. If I multiply, and really I want to do it another line, another step here, right? So here's what was there. Because I want to leave that there for you. If I multiply by the D, it's like D over 1. So it goes away there. Now how do I show that over here, right? I have to multiply like D over 1, or the entire numerator is getting multiplied by that D. This is a quantity now. You have to wrap up in parentheses. So that it implies that every piece has to get multiplied by the D. Every piece of the numerator, because it's really like D over 1, right? Now, as far as rearranging the formula goes, you don't need to distribute. You're good just like that. Then I can say C equals D times the quantity A minus X all over B. Messy over here on the side of the board. If you were more comfortable and you wanted to distribute, that would be okay. All right. Let me show you another possibility if it comes to you, if you recognize it. Everybody's okay with that? Excuse me, I'm going to erase part of this here. Okay. Same first step. We're going to subtract that extra term. And I'm sort of cheating and purposely kind of writing the B, D, that almost look like they're right on top of each other. A bit ago, we divided by the B, and then we turned around and we multiplied by the D. What if we did them both at the same time? Reciprocal, D over B. Now, here, I still might want to write that like this. But that makes the D's and the B's go away. It's just doing the same thing in one step instead of multiply separately, divide separately. And so C might be, and now I could even write this as just exactly like the previous one, you know, D times the parentheses and B on the bottom of a fraction, or just write a fraction first, and then you definitely still need the parentheses. Just a different shape that it's possible to put that in. I know you have something very similar to this in your mom homework. I'll wait for you. Is that okay? Should I wait? Got a copy. Yeah, there's something very simpler. Yeah, I'm trying to make up something similar. You have one in Mon that kind of looks like that. Different letters. And let's get that X alone. This is really very similar to the shape I just made up a minute ago, but I put in some different letters and an actual number, right? Here's the B and D, but I put a number in this time. I want to get that X alone. Here's the term it's in, and there's an extra term. Hopefully that subtract that X, get rid of that one. Hopefully that's clicking, that makes sense. I subtract the C, I'm going to get to here. Now, you think about it, how do you want to get rid of the 2/3, or it's multiplied by 2 and divided by 3, if you want to relate it to the B and the D stuff we just did. You could kind of do it in 2 steps, or you could multiply in 1 step to get rid of the fraction. You see what I'm getting at? How could you cancel out that fraction with 1 step? Now, don't tell me divide by 2/3. How do we divide by that fraction? That's kind of what I'm talking about, though. If I wanted to divide by that, I'm really going to multiply by its reciprocal. Here's what was there, and it's multiply, so that's okay. It doesn't look like they're right next to each other. But on this side, now, if I want to multiply by that reciprocal, just like I did in that last example, I'm going to need to show this as a quantity that's being multiplied by that fraction. Wrap it up. Either that or write 3/2 next to every term. You can do that too. I mean, this really is saying that this is not necessary, but it is definitely one way to do it, right? Divide every term or multiply every term, depending on the operation you're doing. That's legal, but this was good enough right here because these were going to go away, just like that. All right, folks, I really did a little of all the different shapes that you're going to encounter. We're going to ask you to manipulate or rearrange, okay? And we used up the time. So I would encourage you, well, it is part of this week's assignment that's due on Monday. I think problems similar to this solve a formula kind of thing is in that second-handed homework part I assigned. There's one like that in there. It's one that says your answer will be in terms of X. It means there'll still be some X's. It won't just be a number answer. It's like a formula. But I encourage you not to wait till the last minute. I always do that. You know, practice it while it's fresh or something like that. Get your homework done early. All right, folks, so I'm going to stop for today and do your best and send me questions if you're really getting stuck, and I will help as always. Okay?
Thanks for all your help today.
You're welcome. You have a good weekend, everyone, and I'll see you Monday.
See you Monday.